with the collaborative effort of UNINOVA and Atos. So I hope you all will have a good time with the presentation, and if you have any problems, any questions, you just ask me through the chat. Now I will start to record the presentation. Okay. So let's start. So the agenda for today is we're going to have a small overview regarding the specific enabler. What is a specific enabler? And since this specific enabler is composed of two components, which are named as FITMAN tag and trace and FITMAN sensor network, we are going to provide separate presentations for these things, and we'll also have a small live demo in the end. So, what is this specific enabler about? This specific enabler is dedicated for collections of data directly from Shopfloor to provide almost real-time information to the other consumers. So the two types of technologies that we are trying to use is capture and acquire data from tagged objects by making use of RFIDs, and data from network of sensors, which can also be wireless sensors. The major idea behind this specific enabler was to make use of other deliverables from other IRC projects or make use of other open source projects. So, like we can see from here, this specific enabler is composed of two components, FITMAN tag and trace and FITMAN sensor networks. On the lower level, we have like data producers, which are smart objects like the tagged objects or sensors or sensor networks or different types of things. And on the top will be the data consumers, which will be some applications or some services. So each of the components provide best interfaces for service consumers to query for the data or for some small management functionalities. And also this specific enabler will communicate with one other specific enabler from FITMAN that's called secure event management, which will be used for further spans of the events that arise on the Shopfloor. So FITMAN tag and trace is based on FastTrack, which is the open source RFID software, and FITMAN sensor network is based on global sensor network, which is the deliverable from Open IoT project. So what we do is what this specific enabler does is make use of these all the components like FastTrack and GSM to acquire the data from the Shopfloor, and on the top of that we provide our own interface for querying the data, for managing for small management queries, and for interfacing with the secure event management specific network. Now we will start with FITMAN tag and trace, and I think our colleague from Atos will do the presentation. This is.
Hello, Yes?
Yes.
Okay, my name is Jesus Benedicto. I work in Atos Origin, and the idea now is to present a little bit the FITMAN tag and trace. We're going to start with an overview of the FITMAN tag and trace. This component will propose a middleware based on standards. also specification and components to manage several RFID tags. Then the idea is to capture the associated data related to the products in the supply chain and dispatch this data to the client application. At the same time, it will provide services to manage the tags, to capture the data from all of these tags, manage events, and also to notify to the applications. And for sure, it will be possible to make queries to know the status of the different products or assets. Also, when some product is shipped, the time information or location of a product, article, pallet or container, or other several objects that could be in the shop floor in the factories. Then, as main objectives of this component related to the factory domain will be to identify individual products, also cases, boxes, lots, assets, and the idea is to take individually all of them. At the same time, we will capture the data about the movement of the physical assets, creating visibility for the upper layers on the factory, for the business and for the management. It will be possible to know where is located in each moment all of the products that we will need to trace. For that, we will offer a query data about the traceability and tracking the several target objects, and also to manage events and notifications. Finally, the idea is to be able to change data with the IT applications and trading partners to turn visibility into information and action, and we will react more quickly to the several situations. Then, the key features on the requirements of this component, it will be focused on the data standard normatives references. It will cover the ISO, UNS, FACT, ETF, and W3C. For sure, the component will be extensively interoperable and scalable. All of them will be the main feature extracted from the GC1 system, which conforms the state and based on the GCU architecture principles. For sure, it will be forward-looking reuse of components, helping in the simplicity of the development. Technologically, it will be independent. It will be offers several security inside the shop floor regarding the traceability of the assets. Then, as commented before my colleague, FITMAN Trace and Trace is based on the FOSTRAC. FOSTRAC is an RFID software platform, open source, that implements the GCU and APC network, and mainly offers the following solutions. For simple integrations, offers an EPC Global Certified FOSTRAC APC and for RFID. For application developers or RFID solutions, offer several Java libraries of FOSTRAC for the non-custom parts of the application. And then the main important component, probably we can say that is the alt server. The alt server is in charge to communicate, is the part to communicate software and hardware. So in this way, is in charge to manage the interaction with the RFID readers. And then also will provide the RFID data filtering and collection features. when we receive the data from the different tags, it'll allow to filter and collect the data from the RFID readers. Also collect and filter the information provided by the devices using different adapters of readers. Mainly is focused on the LLRP devices, but if we have another kind of devices that they are not supported by the LLRP, we can use the HAL adapter, because in this case we're using Java Octets and abstraction on several classes. Then, in top of the AL server, we are going to develop the management and query interface. It will be in charge to ask the AL server, or also the EPC repository, who is part of the FOSTRAC, in order to receive this different information about the different tags that we want to monitoring. In this case, it will be offered and RESTful HTTP binding. And then in the other side, we're going to have another interface who will be in charge to register and manage different types of events that we're going to capture. And also it will be in charge to connect the data retrieved from the AL server or for the EPIC repository to another component called security management, in order to distribute this data. The function of this security management will be more or less like a public subscriber. So the idea is to send information to this component and then to distribute for the different subscribers. Then the major component that has this component, also FOSTRAC, because it's the main component of the FITMAN track and trace. The idea is to elevate the level of abstraction for application, also to hide the different or the complexity for the developers, also regarding the device details. Be able to share the data among the multiple applications, and at the same time to reduce the volume of data from readers to applications. As I commented before, they will offer several interfaces. One of them will be to retrieve the data directly for the EPC repository or from the AL server. And it will be integrated easily using several standards like XML. It will be based on HTTP, HTTPS protocols, and TCP/IP. It will be translate information received in HTML format from the base to events and standardized data format specified by the EPC global. And also will manage and query, configure and capture the data from the device to the applications. So in the next slide we can see we haven't any demonstration for this component at this moment, because it's mandatory to have several tags and devices to read the information. We have several prototypes regarding capturing data from an emulator that also is provided by FOSTRAC. And in this slide we can see an example of XML message managed by the AL server. As you can see, it's an post HTTP, and there in the XML file we have the different information that we're retrieving for the tag RFID. So for this component, this is all the information. Now Sudeep will explain the other component that compose the Shopfloor data collection specific enabler.
Okay. Thank you, Sis. I hope you can hear me. Now we will talk about the FITMAN sensor network, another component of this specific enabler. So the major objectives of this component is to provide a framework that runs on one of our computer that's acting as a server that will form the backbone for acquiring data from sensor networks, different types of sensors. The important idea behind this component is to extract the implementation details to access to the sensor data and to define data streaming processing on the top of that, so that the users, the consumers, or the people developing applications on the top of the network don't have to be aware of all the implementation details of the sensor specification. And all the important objectives is to provide HTTP binding for management functionalities and data queries, so that other consuming applications can make use of the acquired data through HTTP protocol. Another important objective is for the subscription and management, so that the new available data can be sent as notifications to the consuming applications, and to integrate with the secure event management specific enabler for further dispatching of the events that occur in the Shopfloor. So this is the generic high-level architecture of FITMAN sensor networks. So like we said, it's based on GSM. So we use the components from GSM, like virtual sensor processor, virtual sensor description, virtual sensors, and a number of components that they have used to define the GSM server. And on the lower level, there are wrappers. Wrappers are the specific implementations for different types of sensors, and that's the reason they are responsible for collecting data from different sensors that are connected to the server. So on the top of the wrappers, there are virtual sensors. So virtual sensors are, like we said, are the abstractions of the implementation of the sensors. But we will have a more detailed explanations on this on the next slide. On the top is management and query interface, and even configuration and notification interface. So management and query interface allows for addition and deletion of virtual sensors. Like we already said, this GSM is based on all the concepts of virtual sensors rather than on the concept of sensors, because virtual sensors actually provide abstractions over the sensors, and that is the place where you can define all the rules and the way how you process the data that has been collected from the sensors. So, including selecting the sensor from which you want to collect the data. And this management and query interface also provides HTTP binding for the query control interface. And the other one is for event configuration notifications. So it will be for subscription and management of registered subscriptions and provide live data, and interfacing with security event management specific enabler. So the major components of FITMAN is like wrappers, virtual sensor descriptions, and virtual sensors processing. So wrappers are the implementations of different types of sensors. Like we provide, not we, but JSON provides a number of wrappers, and if we wrappers for different types of sensors, for the serial port, for USB ports, for even to acquire data from other web interfaces, like Twitter or something like that. So these are actually, the wrappers are actually responsible for collecting the data from Shopfloor. Within the domain of FITMAN, only the sensor networks that are directly connected in the Shopfloor will be considered, so that a serial port or USB port can be used for connecting the sensors with the server. So if there is a sync that connects to the server to the serial or USB port, and that sync connects to the sensor networks through Bluetooth, then you can easily acquire data. And then the next part is the virtual sensors. It's the abstraction of the real sensors. And the important thing about virtual sensors is you can combine the data that come from different types of sensors that will be required for different types of scenarios. We will see one example in the demo that we will have at the end. All the virtual sensors are defined by making use of XML files. That makes it easier for the definitions of the virtual sensors, where you can specify the wrapper that will be used, the different predicates that will be applicable, like the sensor that you want to use, and you can write queries with SQL-like statements. And then there will be the virtual sensor processing file that will be responsible for producing streams that will be used for storing. So now here we will see a simple example of virtual sensors. Like we already said, JSON is all about virtual sensors rather than about sensors. So, like for instance, this simple example has, the virtual sensors is named multi-format temperature handler, one or whatever. So, for this we have defined, so this virtual sensors make use of this processing class. So, this is a simple Java class that we have, and the class name is breeze virtual sensors. So, this processing class will be responsible for generating the streams, output streams, from the wrapper which actually gives the data. So here you can define the output boxes. So we said that we just need the light and temperature, and you can even define the types. And then other things is like you can provide the addressing, so that it can be mapped on the Google map and can be viewed where the positions of the sensors and all those things, details, even though that's not the important part for us for now, but this is one additional feature that you can define in virtual sensors. And then then there will be streams, and when you define this stream, so then there will be the address where you define the wrapper from where the wrapper that will be used for collecting the data. Each wrapper can have number of predicates. Like for instance, in this one we have a really simple predicate, but with other cases you can have predicates that will actually that you can use actually to select the sensor that you will use to collect the data. So in the demo example that we'll be showing, we'll have a predicate that exactly says which sensor you want to use to collect the data. And then you will have then you can write the query on that will be used for collection of the data. And these queries are SQL-like statements, so these are very easy to handle. So with these XML definitions, we can see that defining a virtual sensor is quite a easy task, and it is quite manageable. And this will abstract. This will avoid the the users from having to know the implementation details of how the data is acquired from the sensors. The functionalities that this component provides are all provided through HTTP binding. The format is the server name, JSON, and the request type. There are different types of request type that are actually identified by codes. So, for instance, the first one is request list virtual sensors. So, with this HTTP link, you can list all the virtual sensors that has been uploaded in the server. You can add a new virtual sensor with a request that is number 119. You can delete the virtual sensors. You can request the output format for each virtual sensor by providing the name of the virtual sensor. You can write different types of queries to acquire data from the specified virtual sensors. And like the first one will give all the data, the second one will give you the data for the last 3 occurrences of the data, and the last one will give you the data based on the condition that the temperature is greater than 99. And the other one is to acquire the complete set of data. So the first one there are like 2 formats that you can get the data from. You can get the data as XML. The first one will be the default, will be the XML. And if you want the data as a CSV file, you can also download it as a CSV file. While acquiring data, you can also apply different conditions and specify only the fields that you want to select. And one last simple functionality would be to request shutdown in case when there might be scenarios when you want to shut down the sensor networks. So that will stop from acquiring the data for the time being, and you can restart again if you want to continue acquiring the data again. So these are the functionalities that are provided by this specific enabler so far. So in the next release, because of the tight schedules, we couldn't complete everything. So in the next release, which will be approximately in like 15th December, we will complete the subscription management module where consumers can subscribe to the specific enabler, and whenever new data will be available based on the conditions that they provide, the data can be pushed to the subscriber. And then event configuration notification module will be used for interfacing with the secure event management specific enabler. So now we will provide a small live demo. The next part will be a small live demo. So where we will provide a simple web app that we have developed based on the CSN server. So we will try to I will provide 2 scenarios. One will be a really simple scenario of adding a temperature monitoring sensor, and another one will be a bit complicated in the sense that we will be making use of 2 different sensors to define the condition, and the output will be based on the input of two sensors, and it will be manipulated by one virtual sensor description. So only one virtual sensor will be used to combine inputs from two different sensors. So I think before we go for a demo, I would like to ask if you have any confusions or if you want to make any questions. If no, I will go to the live demo. I think I can go to the live demo. Can you, I hope you can see my screen. This one is complicated. Someone can just tell me if you can see my screen. This one signal would be good. Okay, perfect. So thank you, Xavier. So this is a simple web application that we made to demonstrate use of sensor network. So since now we don't have any virtual sensors, there is no data that's available. So because virtual sensors are actually used for interfacing with the sensors. So let's use a simple. We have this small way to add virtual sensors to the server. So let's choose a file. So before I selected a simple virtual sensor description file. I will have to upload it. So this is the simple virtual sensor that I actually added. So it's a simple temperature handler. It makes use of the wrapper that's called the multi-format wrapper. So it selects the default temperature sensor that had been used, and then it has like the query that we can select. So after this sensor has been added, you can see the temperature that the sensor is loading. You can select this time to check how often you want to refresh the data that has been collected. You can see the temperature handler being in the here. You can, okay, my interface is not good, but this cross will help you to, if you want to delete the temperature handler, then you can just remove the temperature handler. This is a simple scenario of using one sensor to monitor the temperature by making use of the sensors. Now there will be another one that I call it monitoring virtual sensors. These virtual sensors make use of two sources. So the first one is the source. It's like the simple temperature handler that we had before. So it just selects the temperature, light, and all the things from the wrapper. And the second one selects is for monitoring, that makes use of the cam to monitor the room. So here, like I said even before, like the wrappers, when you define the wrapper, you can provide different predicates that will actually help you to select the device. So here I'm selecting my default device from my own default webcam from my camera for this demo. So, and what it says is like, there are two sources that we have here. The output is based on this query that we have selected. So it says, provide me the image that has been collected from the webcam and provide me the temperature that has been collected from the other source. If the temperature is greater than 50, so if the temperature is greater than 50, then it will give me the screenshot of the current situation of the room. Let me add this. Scenario, this complex scenario shows that we can form virtual sensors that combines inputs from different wrappers. So here now we have another monitoring sensor. So based on, so if, like we said, the temperature was, so it provided the image that first. Okay, it's me. Sorry. So like with this condition, this was the scenario where you can combine the inputs from different two conditions. Like this monitoring, we can say we can see those things. We what example for now is like, if based on this source and this source needs this package, you can write the conditions so that you can send an email to I was trying to demonstrate also this scenario, but I couldn't install the things for free to be able to send the text messages. So this to do those things too. Yeah, so I think these two were helpful to understand the working of the sensors of the FITMAN sensor. Okay, so thanks for your attention, and now we will go to question and answers if there are any. So for the details, you can follow us at the FITMAN website for further information. Follow us also on Twitter, and the details specific neighbor is available in FITMAN. We are continuously updating the information in the catalog too. So we see on the roadmap that by 15th of December we're going to provide a new release. So so stay tuned, and get further, contact us if you need further information. Thank you. I think let's go to the questions or if anyone has anything to ask. Thank you. Can send the message in the chat. So no questions. Who has questions? Thank you everyone for having fun. Okay, thank you, Javier, for the question. Currently, the scenarios that I presented or that I represented is not based on any exact real industrial scenario, but this will be done with the partners of the project. So there are a number of trials that will make use of the RFID tags and sensor networks to monitor their Shopfloor. So in the end, it will be used in real industrial scenario. It's a specific neighbor, not only Whirlpool, Constable is also using this scenario. I think there is the Augusta is also trying to make use of this scenario, but with the first four components extracts, and also Pacinza, yeah. Pacinza is going to make use of the matrix component. Thank you, Javier. I think nobody has any more questions. I'd like to thank everyone for being present in the webinar. Feel free to contact us through other ways if you need further information or how you can get the specific enabler. Just to make a small note, all the specific enablers are open source, so if you even need the code and if you want to fit, you are always welcomed. Everyone, once again.
Okay, thank you very much, Sudeep.
Thank you.